Okay, so let's look at functions. Now this is some new notation that you need. That means a function of x is equal to 2x plus 1. Now that is the same thing as a function machine. You could have written it as times 2 and then plus 1. That is the exact same thing. Now the notation that you need to know really is for this, when x equals 2, you would write that as f2. And that would be, instead of x, you would use the number 2. So that would be 2 times 2, because that's our x here, plus 1. So that would equal 5. If we look here at an inverse function, so that is f minus 1 of x. So the inverse function of x. So our function is 3x minus 7. Now we want to swap that x for another letter, let's say y. So we've got x equals 3y minus 7. You see, all we've done is swap that x for a y. Then we're going to rearrange it to make it y equals. So x plus 7 is 3y, and y equals x plus 7 divided by 3. So our inverse function is x plus 7 divided by 3. Now a composite function is where we have two functions. So we've got f of x and g of x. Those are our two functions. So what is fg of x? So all that means, okay, is we're going to put that function of g into the function of x. So it's a bit more algebra here. So this notation here is the same as this. So we know that g of x is 6x squared minus 4. So the function of 6x squared minus 4. Now, what does that mean? If it's inside the bracket, we're going to substitute it as x. So here we go. We've got 2x, so 2 times 6x squared minus 4 plus 1. So we've got 12x squared minus 8 plus 1. 12x squared minus 7. And that would be our answer for fg of x. Okay, here's another composite function, but here we've got a number, not an x in here. Okay, so let's have a look. So we've got f of g of x. So we know that our g of x here is 6x minus 4, okay? But it's g of 3. So we know that it's 6 times 3 minus 4. Okay, and that is the same as 18 minus 4, 14. So now we've just going back to the start. Function of 14, well that would be 14 squared minus 5. Which is 191. Cool.